do a little quiz that I think everybody did correctly, and that's very good. That's the way to go. It was exercise 17. In fact, I believe I did this exercise on Monday. So the way I did it, I recommended to eliminate letter y by adding these two equations with each other. So we end up with 2x on the left side and 8 and 4, which is 12 on the right side. That tells us that x is equal to number 6. So once one of the unknowns is found, we substitute it to another equation. In fact, that method of substitution is very popular for ending this, even though we could possibly eliminate x's as well if we subtracted y's, but usually substitute. So instead of x, I put 6 with y equals to 8 in the first equation. And we know that it doesn't matter. You plug this in the first or in the second equation, the answer is the same. And that's a nice part of math. No matter how you do problem, the answer is the same. You always get to the same conclusion. And if not, then it means there is a mistake. So we also see that y is 2, x is 6, and that's made me very happy. The fact that you actually pretty much everybody who took the quiz did it right. So that's perfect. So I'd like to do another exercise, a bigger system, the system of equations with 3 of these variables and 3 unknowns. And then we'll see what else is in this nice chapter. So try one, let's say number 49 to start. And I would also need plenty of room for this, right? So always use plenty of paper. By the way, I also posted your approximate grades on Canvas. So on Canvas, I put grades, and that's approximate. So some people probably missed the quiz or something, so the grade is a little lower. So get back on track, start taking those quizzes. If you want, you can send me the answers by email for your missing quizzes, or just do a couple of exercises and send it to me. And that'd be it. Just make sure you say extra credit so I know what this is for, because homework is not due yet. We still accumulating more material, but again, what's on Canvas, that's just stays on Canvas. So it's not really the grade for the class that you will get at the end of this semester, because I'm gonna post it in different website. And this one is just for you to see how you're doing so far in the beginning of semester, and anything is possible. You can, I'm sure, improve it, and I don't mind. I usually let my students get better grades if they want. Just do a few problems, call them extra credit. One can say, what problems? Well, any problems that you like to do. I don't really tell you exactly which ones, but of course, from the sections that we covered so far, you can do the same problems I did in class as well. So anyways, let me share the board and do problem number 49. And this is the system with 3 equations and 3 unknowns. We need to find all these 3 unknowns, x and y and z as well. So first equation is 2x plus minus 2y, and also plus 3z is equal to 6. And the second equation is 4x minus 3y, and also plus 2z is equal to 0. And then the other equation is 2x with negative sign, and 3y minus 7z. is equal to 1. So first of all, you want to copy this exactly the same way it is. So this is going to be a good start always to make sure that you copied everything correctly. Otherwise, well, the answer is going to be not the same. And our goal for these exercises is to just get used to the structure of solving them. So we need to produce zeros underneath the first equation in the positions of x. So I keep my first equation unchanged, just the way it is. I'm not going to touch it until very end. Second equation needs to start with a 0. So the point is we have to take the first term, 2x, and then somehow kill that 4x. And looks like we just need to multiply it by -2. So minus 2x and 2x will give us -4x, and 4x will produce that 0 that we really want. So with this in mind, I need to multiply by -2 all of these entries and then put them together with whatever is underneath, like that. So we're going to have minus and minus plus 4y minus 3. So 4 minus 3 is just 1y. So we always put the sign, so it's plus y. And then z's, we have -6. 3 times 2 is 6 with minus sign, and 2 is -4 times z is equal to -12, right? Because 6 times 2 is 12 with a minus sign, with a 0 is just a -12. So it's a great start. And now I need another 0 underneath that x term, but produced from my third equation. So now I'm going to need to just put these two together. It looks like 2x and minus 2x will give us a 0 that we need. So I want to clean this a little bit so they don't bother me, this minus 2's. And I just want to collect my row number 1 and row number 3 simply to add them together. So I'm going to be adding minus 2y and 3y, so that'd be plus y. And then also minus 7z and 3z is going to be -4z. And then on the other side, we have a 6 with a 1, which is 7. And now I'm going to need to work on this little system of 2 equations and 2 unknowns, because I can solve it just like we did already on the quiz. How to solve it? Well, looks like I just can subtract these equations. And notice when I subtract, everything on the left side will disappear, because y and y will give you 0, same, minus 4z, and subtract another minus 4z will give us a 0. And then when I subtract 7 from minus 12, it would be minus 19. And this is not correct. So remember what this means? No solution. That's the case. That doesn't happen too often, but if something that we produce is not making sense, because 0 is not equal to -19, it means that we can't solve this system. It has no solution for x, y, and z. And that's okay. So you can just leave it like that. No solution. Doesn't happen too often, but we found one. How about that? So what I can do is just solve more of the exercises, and to be able to do this, I guess I'm moving to the next section and see what happens here in section 2 of chapter 11. And they actually deal with same exercises, but they want to use so-called matrices to solve them. Remember, matrix is a table of numbers. So why would they do that? Well, I guess the idea here is to write a little bit less. So instead of say 3x and 4y and 2x and 3y, they just put no x's, no y. So they just put those coefficients that they have with x's and y's here. And then they put the bar. And so instead of equal signs, they put bar. And the numbers -6 and -5. So they just work with this system, but now they utilize a little bit less of writing. So if I go, for example, to the previous exercise, I can also write this as a matrix. So they put these bars around the matrix. It's not bars, like brackets. And then they have coefficients 6, 0, and 1. Those are on the right side of this bunch of equations. And now on the left side, I can put just coefficients, such as a 2, -2 is with y, and 3 is with z. You see, I didn't put those x, y's, and z. So they say that's probably easier because there's a little less mess in here. My goal is just to introduce you with this because I'm not sure if we need to do same thing, but using matrix, because we already know how to use the triangulation process for this. But this section just has more problems for us to practice on. That's why I just want to do one exercise here to show you that's really pretty much the same thing here in this section. So I'm going to be going back to my textbook, move to the next group of exercises in 11.3, and you will see that these are exact same problems. So we don't really learn anything new, but they utilizing those little matrices in order to solve the systems. I guess I'm not gonna worry about matrices because it's just something that we're not gonna utilize much in later sections, but just to show you how to solve more of these systems of equations. So I'm going to work out another exercise, but now from this section 2 of chapter 11. So why don't I try to work out one of these systems just a standard way, the way we already know how to work out those exercises. So let's say starting 27, that's where more problems appear. And I will do maybe exercise number, say, which one should I try? 49, something like that. It's 3x3 system, right? Let me try one more. That should be good enough for that because it's really continue doing the same thing. I could have skipped that section, but why don't I just enjoy another exercise first? Then we're gonna end with that. So let me get some more room. Go to another page here. And let's see what's here. 49 is a system of equations, which is on the first place plus x minus 2y, and 3z is equal to 7. So we don't really care what the numbers are. We're just gonna follow the process, and that's the whole idea of this. So if you know how to do one of these exercises, then you basically know how to do all of them because they're just the same pattern for solution. So we get a 4. And finally, -3x with a 2y, and then subtract 2z is equal to -10. So perfectly nice system, 3 equations and 3 unknowns. So I'm not going to use matrix to solve it. I just do it the way we used to. So I'm going to leave my first equation the way it is. Copy x minus 2y is equal plus 3z is equal to 7. And then we're going to need to produce 0 under x, right? Here as well as there. That's our goal. So how to get 0 out of 2x? Well, I need negative 2x, right? So it'll be minus 2x and 2x. That's how I get 0. And of course, I need to now multiply by negative 2x the whole equation number 1, and then add these two corresponding terms down below. So we're going to have y and 4y, right? Minus 2 times minus 2 is positive 4. So I add it with another y, so this be 5 y's. And that's great. So now we have a negative 6z, because minus 2 times 3 is negative 6. Another z will be negative 5, because we subtract plus z, and negative 6z is 5, but with a minus sign, right? Okay, on the other side, we have a negative 14. Minus 14 plus 4 is negative 10. And this is nice because this system could be, this equation could be turned right away into a simpler one. Divide by 2 all of these terms, so you get y minus z is negative 2. So what did you just do? Well, I divided by 5 because I saw these numbers, they all divisible by 5, and it's always nice style to keep it as simple as possible. And equation you can divide or multiply by the same number on both sides, so you can
Excuse me?
nicer looking, smaller coefficients in your equation.
Excuse me?
So we have a good start, and now we need to get another 0 here. And I will need to have minus 3x, so plus 3x, right? 3x minus 3x, we get a 0. And of course, we have to use the first equation for all these manipulations with the first terms. So this way you don't get confused. So I use 3 multiplied by my first equation, and then collect these terms with whatever is under. So let's do that. We now gonna get minus 6 and 2, which is negative 4 times y. Again, minus 2 times 3 is negative 6, and down below is plus 2, so it's minus 4. So don't hurry, otherwise you can make a mistake, and who needs that, right? So 3 and 3 is 9 z's, minus 2 will be positive 7z. We always need to put signs. So it's plus 7z, double check. 3 times 3 is 9, minus 2, 7. Great. What's on the right side? Looks like 21, right? 3 times 7, 21. Subtract 10 is 11. Okay, maybe I can bring this separately to the right side, and this will enable me to solve it. Just don't forget to copy it the way it is, minus 4 and equals to 11. So basically, I'm solving a little system here. First equation is gonna patiently wait for us to find y and z, and looks like it'd be pretty natural to multiply by 4, right? Because we get 4y and minus 4y, so that will cancel my y's. Okay, so I can multiply by 4 the first equation, and then add with terms down below. So it'll be 7 minus 4 plus 3z is equal to 11 minus 8. That's 3. And this is great. I found z is equal to 1. And then I can also find y. Now I'm going to use equation number 1 here. Smaller coefficients. It makes a little bit nicer solution. So instead of z, I put 1 is equal to negative 2, right? So instead of z, I just replaced it with what I just found, 1. So what about y? Well, I add 1 on both sides, and I get negative 1. Okay, y is negative 1. And now we go for the last variable for our letter x. So I'm going to use it here, say x minus 2y, 2 times -1. People usually put parentheses around, plus 3 times z, which is 3 times +1, right, is equal to 7. Okay, so what about x? Let's put the numbers together. So it'll be +2 and +3. So it's 5. So I can say it's x plus 5 is equal to 7. And then x is equal to number 2, right? 2 plus 5 is 7. So x is also 5. So once you found these, that's it. The problem is done. So they actually asked me to write a matrix for this system. So you could write a matrix if you want to for this entire system of equations. You can put 1 minus 2, 3, and then after the bar you put 7. That's my first equation. Second will be 2, 1, 1, and that's 4. And finally, the third equation is -3 and 2, and -2 is equal to -10. So this is our, they say, augmented matrix because it has this equal signs that the right side. So that's our first encounter with matrices that we have in our class, and that's pretty much all we need here. So let me return back to the textbook and show you that truly nothing new, but more of these systems of equations. They even have 4 unknowns, which is really lengthy procedure to work out. I'm not going to be doing those, so they don't have to worry about 4 unknowns, because they could put 5 unknowns, they could put 100 unknowns, get huge systems of equation, but what for? So I don't think we're going to need that. So I would say this section is kind of voluntarily, but I wanted to show you the matrices. That was the idea, matrices. And in the next section, we're going to deal with those matrices a little bit more. We're going to produce other things related to it, but that's going to be done on Monday. I don't think I need to worry about this. Now we have plenty of time, so we'll keep working on chapter 11 next week as well. So I'm not giving you a quiz. I'm pretty happy with your result. I think you deserve a little break. It's a weekend, right? So looks like not too many people here anyways. And that's good because you deserve to recharge, have a little bit time for yourself. And we're going to continue with third section of chapter 11 on Monday. I'm pretty happy with the results for the class, and if there's anything you want to talk to me, please do that. Otherwise, I guess I'm gonna let you go, and no quiz today. Today is Friday, so I think you deserve a break.